a break about 11 o'clock. So please don't stop to listen and watch our presentations. Next up is Björn Wickman from Chalmers, University of Technology in Gothenburg. Björn, most welcome. And you are muted, but we can see your screen.
Very good. Thanks a lot.
Maybe you can try to put it in presentation mode. Yeah, perfectly well.
Thank you very much. Yes, so my name is Björn Wickman. I'm an associate professor at Chalmers, University of Technology, and I'm here to present the project, the pre-study we've done, removal of mercury from sulfuric acid production. And we've done this together with Boliden, a startup company from Chalmers called Etken, IVL, Svenska Miljöinstitutet, and Chalmers Innovation Office. So the project just ended last month, and take it from the beginning, the goals and a bit of background. Sulfuric acid produced in smelters can sometimes have rather high levels of mercury. And give you a few numbers, the qualities that we're dealing with are technical quality, 300 micrograms of mercury per kilo allowed, and bleaching quality, 80 micrograms per kilo mercury allowed. And currently, there are no techniques to remove mercury from concentrated sulfuric acid. But we had indications that a novel electrochemical techniques developed in our lab might be able to solve this. So the goal in the pre-study was to scale up our previous lab tests done in about 50 milliliters to treat 20 liters of concentrated sulfuric acid from Boliden's one of Boliden's smelters. So that's a scale up on 400 times. And we wanted to reach that technical quality in less than 7 days and evaluate the possibility to even reach bleaching quality. And we wanted to do this, want to identify stable and efficient electrode materials to do this. And the results we obtained, we managed to very successfully scale up to 20 liters. This is the results here. We show the concentration of mercury on the y-axis and time here. So we've done 2 runs, batch 1 and 2, and we see that we meet technical quality in less than 20 hours and bleaching quality in about 80 hours. So that note, very successful. However, we noticed some stability problems with the electrodes used. The first set of electrodes we used were based on stainless steel, actually same type of steel used in the containers to store the acid, but for some reason they're not stable and used as electrodes, although we tried several different types from several different manufacturers. So we had to go back to the drawing table and look for new materials. And just the last month of the project, we performed very successful tests with a carbon-based material instead that shows no sign of degradation and very efficient substrate for removing mercury. So what we want to do in the next step is to write a scientific article on the progress of the scale-up and industrialization of this process. We need to do more tests on this new carbon material, and we need to optimize and develop the regeneration procedure. The idea is that we can remove mercury from the acid and then deposit that mercury in a smaller volume, controlled, and then take care of the mercury. And take this all the way to a flow reactor prototype. And hopefully be able to scale this up to a pilot reactor to treat 1 ton of acid that we hope to do at Boliden site, maybe in a full innovation project with Swedish Mining Innovation. And with that, I'd just like to thank everyone involved in this from Chalmers and from Etken, Boliden, and IVL and Chalmers Innovation Office, and of course the Swedish Mining Innovation for supporting this. Thank you very much.
Thanks a lot, Björn. Very interesting presentation, very interesting results, and of course, most valuable for our society. So thanks a lot. I have a question to Anders Enetjärn. You're supposed to hold your presentation from Ecogain, where we see Carina Andersson in the schedule. Maybe you need to have your now, because I know that you are sort of in a hurry. Is that right?
Thank you. That's right. I have to be on another panel at 11.
Yeah, then we help each other out. So you will go in now, and then after you, we will have Jörgen Sjögren from SLU. So please, Anders.
Okay, thank you so much. I'm Anders Andersson. I'm the founder of Ecogain and also the initiator of the project that went for the project manager, Katerina Andersson. And this project is CLIMB, which has the name of Changing Land Use Impact on Biodiversity. And as you can see, we have partners from 4 different kind of industries: the extractives, the real estate, energy, and forestry. And from extractives, we have partners from Boliden, Cement, and LKB. And this project runs for 2 years, and it's about to finish in the beginning of next year. And the goals of this CLIMB project is actually we are addressing one very big challenge when it comes to biodiversity. That is how to make it measurable. So we are going to develop a model to measure and evaluate biodiversity impacts when we are facing land use change in Sweden. And we base our development on scientific methods, and the result will be widely applicable, and we do it in a cross-sectional way with several industries, and the result will be open. Will be available through open access. And as you see to the right, we take a lot of impressions from what is going on in other parts of the world, like the biodiversity metric from the British government and other initiatives on measuring biodiversity. And our expected effects on this is that we will increase predictability in the permit processes, because biodiversity is always a huge challenge when it comes to permit processes for all kinds of industries. And we also want to develop a metric that is able to be integrated into the corporate business models. And we aim to also make biodiversity issues more cost efficient and therefore go towards sustainability. The results so far is that besides continuously reviewing international standards and biodiversity metrics, we have developed 2 prototypes with different indicators, and we have tested them during this last summer on prioritized sites that belong to our partners. You can see them on the map to the right in all different sites of Sweden. And we have a metric outcome that we call biodiversity points, which will be the metrics that we talk about. We've had some real insights from analysis together with the partners, with different experts, for example, the academia, and different reference groups with among stakeholders. And so far, right now we are having 9 interactive demos workshops on this test phase results during September and November. And the upcoming activities within CLIMB and the next steps are that yes. Okay, thank you. We are managing some really difficult trade-offs and necessary trade-offs which is, for example, between the amount of data collection versus time management, the trade-off between simplicity and acceptance, for example. And there will be a proposed metric for the steering committee of the CLIMB project in December, and we will start implementing a new strategy with partners, experts and reference group in the last meeting in the beginning of next year. So it's going right in the right direction, and we are looking for some really nice results. That's all for me.
Thanks a lot, Anders, and thank you for being able to attend even if the schedule was very tight today. Interesting results so far, and we are waiting to hear more from you a few months from now. So thanks again, and now we will listen to Jörgen Sjögren from Swedish University of Agriculture and Sciences. So please, Jörgen, and we can see your screen, and now we can see you.
Thank you very much, and thank you for having me. I apologize for not being able to use the same format on my presentation as the other presenters here, so you will see a lot of SLU there. Sorry for that.
Looking very well.
Okay, thank you. So I'm going to talk about our project impact of mining dust deposition on forest biodiversity and ecosystem services. We call this MINEDUST. And my name is then Jörgen Sjögren. I'm an associate professor here at SLU. Let me see. The partners are of course us then at SLU, LKAB, Boliden, and Sveaskog, and we're obviously financed by the Swedish Mining Innovation, and very grateful for that. The researchers in this project is then me, Marie Jönsson at Swedish Species Information Center, and Joakim Hjeltén at the same department as me then here in Umeå. The background to this project is that it has been studied for quite some time, and also stated that the environmental impact of mines on site can be quite remarkable. But what is less known is whether or not there are indirect effects in the surrounding landscape. For instance, the mines, they constitute large openings in the forest that can lead to a change in microclimate in the surrounding of the mine. There might also be soil pollutions due to emissions that can travel quite some distance from the mine. And then obviously also there might be a spread of dust from both mine and sand reservoir that we then are going to study in this project. I say that we will because we have just started this project. It started this spring, so we have not so much results to talk about. But the aim of the project is to investigate how dust from mines affect both biodiversity, ecosystem services, and also look into more depth of the biology of certain specific species. And it's interesting here to note that the dust can have both physical and chemical effects. So the physical might be that the dust might cover some of the plants, so they might have problems photosynthesizing. And also then obviously the chemical effects that the plants in this case might end up having these chemical substances in their tissues. So we have started this year, this summer, by visiting the two mining areas that we will be using. It's Svappavaara and Aitik. And we will also look at the surrounding landscape. In this case, we are focusing on pine-dominated forests that surround these mining areas. We will be looking at, so you see here the dots surrounding the mines here. The blue dots are where we have kind of recent historical data on dust deposition that has been collected for quite a couple of years at least. The red dots are where we plan on making our measurements so far. We're expanding this a bit, so it's not fully decided yet. And what are we going to do? Well, we will
again, 1 minute.
Thank you. We will examine sample areas, look at the forest type and structure, measure climate variables, and measure this dust deposition. And we'll look at the various species and species groups and ecosystem services, and try to measure then the growth and vitality of different plants that we will survey in depth. We will supplement this to be able to further control the environment with potted plants, subjecting them to different levels of deposition, and measure certain variables that are of interest to us and that we think might be affected by the dust. The project time plan is that it started this May. We have done preparations, including field visits and a pilot study. So next year and the year after that, we will do our full-scale field and experimental work and report after that. And by that, I thank you for your attention, and these are my contact informations.
Thanks a lot, and it will be very, very interesting to follow your project. And sometimes we feel it's so important as well to hear from when you start a project, because it gets a lot of thoughts there. So thanks a lot, Jörgen.
Thank you.
And hope you will come to successful results, of course. All right, next out is Tim Hunt from Etken Teknologi, and I can see you there, Tim, so it's just for you to share your screen.
Yep. Hi, Nicholas. Thank you, everybody. Can you see my screen okay?
Perfect.
Yep, great. So my name is Tim Hunt. We have been working for the last 18 months on an explosives that substitutes ammonium nitrate out for hydrogen peroxide as the primary oxidizer. The point of this is that ammonium nitrate is a great explosives, very safe, very effective, but it does have a massive environmental cost due mainly to the energy required to produce it. It also generates quite a lot of nitrous oxide gas, so NOx, NO 2 and 3, which is toxic. And that was the primary focus of this trial series, at least, to manage NOx gas, but it also does have significant CO2 benefits as well. So our goals were to develop a stable, cost competitive bulk explosives, like I said, using hydrogen peroxide as the oxidizer. It has been done before, but it hasn't been stabilized before, which was the challenge. In this case, we used a gel, a water gel, which essentially means that all components are water soluble. It, of course, needed to have safety characteristics on par or better than the status quo, and performance characteristics as well had to be on par or better. Otherwise, there's no point really. The results so far, well, like I said, we have wrapped up this project. It is ongoing in the sense that we are not finished with hydrogen peroxide, but this project is completed. But what we managed to do, we received permitting from MSB in Sweden to actually produce and use these explosives. We constructed the first bulk loading unit, which was used with Boliden. Significant procedural and risk assessment work, detonation testing. We used the Swedish Military Research Agency, FOE, to do independent gas profile measurements, velocity of detonation testing, and environmental testing by Boliden. So this was where Boliden actually took our blasted rock mass and their blasted rock mass done with ammonium nitrate explosives, and they compared them, and you can see ours on the green. We've dropped the nitrates right out. Now, it's important to note it wasn't zero because even though it's a nitrate-free explosive, it's because of the residual nitrates in the environment there in Boliden, which all mines and tunnels and blasting areas suffer from. Next step, so while the explosives performed excellently, in a gel form, they're not exactly what Boliden's looking for. That doesn't mean it's a no-go. Essentially, we're looking now at evolving this product to an emulsion, which is a standard product within the industry. An emulsion is essentially two immiscible liquids that are mixed, and so you need to use certain chemicals to permit this. And that is the aspect which is really exciting, which has never been done before. And I think my colleague Thomas Gustafsson will be presenting on that later on today. But you can see on the table on the right there, that is all the KPIs that we had for the project with Boliden. And we hit pretty much all of them except for one or two. So we're very happy with that. Boliden were a massive support, as was Swedish Mining Innovation and Luleå Technical University. Just a couple of quick photos. On the left there, we've got a detonation testing at our firing range. You can see the white smoke. That smoke is predominantly water steam and a bit of CO2. Center shot there, the two pictures in the center, that's a cut of a tunnel, which is, in my opinion, at least the hardest part to get out. So that came out well.
1 minute.
Right, okay, on the right there, we got the full blast profile out. So we ended up firing about 600 kilos rather, of explosives over the trial phase. So yeah, everything went really well, and hugely appreciative of the support we received from Swedish Mining Innovation. And that's me. So thank you very much.
Thank you, Tim. And I mean, this might be a real breakthrough. So we are so interesting to hear more about your results and your testing work in this field. So thanks again. Yes.
Absolutely.
Right.
Thank you very much.
last out before our first pause and last out in this theme, environmental impact, will be Katerina Hruzova from Luleå University of Technology. So Katerina, please.
I hope you can hear me.
We can hear you. We cannot really see you. And if you put on presentation mode, we will see it even better.
You don't see a presentation mode?
No, not really. So this is
okay.
good enough, but it might be able to do it better.
Let me see. I thought it is.
Yeah.
In that case, is it the presentation mode now?
This is the presentation mode. Perfect.
Perfect. Perfect. Dear all, I would like to present to you our project, which is called Lignoflot. It's led by Organosolv, and it's a cooperation of Boliden, Nurion, LTU, and Sevastog. The goals of the project are to totally or partially replace the fossil-based xanthate flotation collectors derivatives with bio-based, biodegradable, hydrophobic, non-toxic Organosolv lignin nanoparticles. The idea is basically to utilize the forest residual resources for sustainable mining processes with both low environmental impact and low carbon footprint. We would like to establish separation process for selective extraction of the base metals. We would like to determine the efficiency of lignin as a flotation collector on various ore types and correlate the efficiency on specific metals with the chemical characteristics of the lignin. The goal is to have optimized flotation process, pilot scale test and evaluation toward TIL7, scale-up potentials of the process, including environmental assessment of the process. So far as the results go, we've managed to isolate and characterize lignin from birch and spruce sawdust. We prepared and characterized lignin nano and microparticles. For this, we are using QCMD, Turbiscan, Zeta Potential, and SEM. We have performed the milling experiments with size and elemental distribution study. So far, we have been testing our lead zinc ore sample, and we find out that lignin selectively improves recovery of lead. As a flotation baselines, we are always using collectorless flotation and xanthate as the industrial baseline. Our target is to have dosage studies and also have the simulation of the flotation circuits. Upcoming activities and the next step, we would like to perform Halimon tube test with pure minerals. We would like to use chalcopyrite, pyrite, galena, and sphalerite. We would like to continue on our lead zinc ore with the dosage studies and flotation tests. When this is done, we would like to continue with a copper ore to see if it can be used in this setup as well. And as a final step, we would like to perform a pilot plant scale flotation test.
Katerina, 1 minute.
And that is it from my side.
Well done. Well done.
Thank you.
And of course, from you as well, very, very interesting. And it will be very exciting to see your results in the end of the project. All right, now everybody, this was the last from environmental impact theme. Now we will have a quarter minute of a break. So we will see each other again 11:15, and then we will start to listen to presenters at the theme metallurgy and recycling. So please welcome back 11:15. Cheers.